I'm Anil Kumar. Let me thank all the viewers and subscribers for taking keen interest in my channel and posting excellent suggestions. We received many questions to answer. Here is one of the best ones received today. Let me thank Mr. Zafri for posting this particular question. It took me quite some time to understand and digest. I thought let me spit it out to all of you, and I hope you will all appreciate it. It is one of the best questions received on polynomials, and I really appreciate it since with this particular example, we can look into all the concepts learned for polynomials. And therefore, are given the heading as Polynomials Review Assignment. Okay, so let's try to understand what is it all about. The question here is, the equation r of t equals to 5 times t to the power of 4 minus 4t cubed plus 19 over 4t squared minus 3 over 2t can be used to model the side effect response r of t in degrees Celsius above or below the normal body temperature 36.8 degrees Celsius of an experimental drug t hours after it was administered. The equation is valid for t greater than 0 and less than 2.2 hours. Due to the stress of temperature change on the body, a second drug is administered at the moment the patient's body temperature starts to exceed 36.9 degrees Celsius. Now there are a lot of options, based on this particular information, and these questions have to be answered. A. Within the context of the problem, what happens when r of t crosses the t-axis? B. Using knowledge about linear and quadratic functions, predict how many times the second drug will have to be administered. C. Predict how many times the patient's temperature can spike, reach maximum or minimum. Explain using rough draft. D. Apply the factor theorem and the quadratic formula to determine the times when the patient's temperature is at the normal body temperature. E. Predict when the second drug will be administered by applying a knowledge of solving polynomial inequalities, and so on it goes, right? Now let us see how to solve such a question, right? So it's a one full page. I have not taken all the parts, but I'm going to answer the first 5 parts of this particular question in this video. So let's begin with the equation itself, which says r of t is equal to 5 times, and within bracket we see that t can be factored out, right? And this equation is valid for time between 0 to 2.5. So let me rewrite this equation as r of t equals to, we'll factor out t first, so we have 5 times t, and within bracket we have t cubed minus 4t squared plus 19 over 4t minus 3 over 2, right? So that becomes the equation. Now to factor this equation, what we see is the coefficient, or rather the constant, is 3 over 2. So what could be possible factors? We need to check that out, right? So 3 by 2 suggests that we could have half, right? So we could have 0.5 or half. So the possible factors which we should try are t equals to half, we could try, right? Means factors of 3 divided by factors of 2. So that means we could apply half, we could apply. We could try 1. We could try 3 by 2 itself. We can try 1.5, right? So factors of 3 is 3 over 2 we could apply, which is 1.5. Okay, let me write 3 over 2 itself. So these are the factors. These are the possible factors. So let's try the value of r for half. Let me write 0.5 here, right? So we'll just convert them all to decimals and then figure it out, right? So if I place half as my value, and of course, as you can see, t equals to 0 is one of our solutions, right? Since it is greater than 0, I'm not taking that, right? Okay. So if I substitute 0.5 here within the brackets, what happens? So we get 0.5 whole cube minus 4 times 0.5 square, okay, plus we have 19 times 0.5 divided by 4, and then we have minus 3 divided by 2. So it gives us a 0. So we do get a 0, right? Since we have got a 0 here, we could divide this equation by t minus 0.5, right? So let's work in decimals. So let's divide it by t minus 0.5. The equation is t cube minus 4t square. 90 divided by 4 will be 4.75, right? T. And minus 3.5 will be minus 1.5. Clear? Now, so first thing we could do t square here. So we get t cube minus 0.5 t square. And when you take this away, we get minus 3.5 t square. Bring down 4.75 t. Now it should be multiplied by 3.5 t, so that will take care of the first term. Minus and minus becomes positive. Half of 3.5, right? So half of 1.75, I could write that. Well, let's do 3.5 divided by 2, and in decimals 1.75. So minus minus becomes plus 1.75 t. So I'm trying to use the minimum space, right? When you take away, we get 4 minus 1 is 3. So we get 3t here minus 1.5. So we could now take care with 3. So we get 3t minus 1.5. As expected, the remainder is 0, right? So we have a quadratic equation to work with, right? So this is t square. So we have this equation. Now let's find the roots of this equation. T square minus 3.5t plus 3, right? So we'll use the quadratic formula, which is t equals to minus b, which is 3.5 plus minus square root of square of 3.5 minus 4 times 3 over 2. So let's calculate this. Let's begin with the square root term, which is 3.5 squared minus 12, and that gives you 1 over 4. So square root will be half, right? Of our answer is half, which is decimal 0.5. So that's a good answer. So we get here 3.5 plus minus 0.5 divided by 2, right? So that gives you two other values, both positive. So if you add this, you get 2 as your, 4 divided by 2 as you eliminate 2 here, right? So 4 divided by 2, and if you take away, you get 1.5. So there are two other roots. Now based on this, whatever we have done, we could write our function r of t as equals to 5t, first factor t minus half, and then we have t minus 1.5, and also t minus 2. So that is how you could actually factor this particular equation. It's a quadratic equation, degree 4, right? So it has 4 zeros, 1, 2, 3, 4 zeros. Now it's a good idea to sketch the curve, and then we can actually answer most of the questions, right? So let me push the page a bit here. Okay, so let's sketch the curve. So I'll do a small sketch here. Okay, fine. Since it is a quadratic equation, leading coefficient is positive, so right side up, right? So we have 1, 0 at 0, then we have at 0.5, then at 1.5, and at 2. So they are equally spaced, right? So it comes down here, goes, and then like this. So let me sketch like this. Okay, so that becomes the graph of this particular function. Perfect. So from here, what you see on this axis is the r of t, and this is your time t. This point here is 2. This is 1.5. Here we have 0.5, and here we have 0. Now, let's answer these questions now. What happens when r of t crosses t-axis? Now, this is your t-axis. So basically, this is our body temperature. If you see the question, it says this is our body temperature, which is 36.8 degrees Celsius. Do you see that? So that is your body temperature. So it says what happens when r of t crosses t. It means that body temperature changes. Either it decreases from normal or it increases, right? So there is a change. Let me write change from normal. Or you could also say deviation, right? From 36.8 degrees Celsius. So that is what it is trying to say. So at these points, if you start, like when the drug is administered, the body temperature actually goes slightly below normal, right? And then it goes to normal, comes back to normal, and then shoots up, and then again tries to come back to normal. That's what it shows, right? Okay. Now, so we have answered first part. Second part. How many times does the second drug will have to be administered? Now, second drug has to be administered if the temperature is 1 degree above, right? The 0.1 degrees. So, when the temperature is greater than, let's read the question where it was. Okay, so here it is. So, they are saying when it is 36.9, normal is 36.8, so 0.1 degrees, just 0.1 degrees. So when the change, I should say, is greater than 36.9 degrees Celsius. So what we are going to do is we are going to draw a straight line here. We'll find the peak also, but seems somewhere above, but below the peak, right? So that is how we'll say a line, correct? So now when it says predict how many times the patient's temperature, this part B, how many times the second drug will have to be administered, right? So you have to give it once as soon as it crosses, but once it does so, then it comes back to normal. You don't have to really give. So that is the effect of the medicine. It comes down. So that is one time you give, right? Now, this point here, we are not sure whether it is between what I'm trying to say, 2.2 or not, right? So the last point, what we should do here is to figure out the value of the function at 2.2, right? So we need to find the value at 2.2 to find whether this point is within our domain or not. So let's do this calculation. Let's calculate the value at 2.2. So when t is 2.2, let me use this equation which we have got here. We get 5 times 2.2 within brackets 2.2 minus 0.5, and then within brackets we have 2.2 minus 1.5, and then within brackets 2.2 minus 2. What do we get? In decimals, we get 2.618. So this value is 2.618. So definitely this value is much, so at 2.2, it seems it is a pretty high value, right? So from this, because the range is given up to 2.2, we will say that definitely somewhere here, this is within our domain, we need to administer the drug. So it will be done twice, as you can see from the graph, right? So 2.2 is probably somewhere here. Is it okay? So we need to administer it twice. So definitely this is not reacting to the second time the medicine is given. Perfect. So some adjustment. So probably once you provide a second drug, it should start from there, right? So that portion should be repeated, maybe. But anyway, from the information, it is twice. Now see, predict how many times the patient's temperature can spike, reach maximum or minimum, explaining using rough draft. Well, this is a fairly good draft, and so we can say from here that it spikes 3 times. 1 right there, second, and 3. So we have 3 times, in which 2 on the lower side and 1 on the higher side. And they seem to be symmetric, right? Now, D is times when the patient's temperature is at normal body temperature. So the normal body temperature is at those x-intercepts. Is it okay? So the normal body temperature is at T equals to 0, T equals to 0.5, 1.5, and 2. And all these are in hours, correct? So all these temperatures, so temperatures are in hours. Is it okay? So those are the times when you have the same as the body temperature. Now E is predict when the second drug will be administered. So it seems that second drug should be administered immediately after 0.5 from the graph, right? So immediately after 2, second drug, right? First time after 0.5, let us say 0.6. So what you could do here is you can do approximation. So I'll not do these calculations, but what you could try is, so 0.5 we know it is normal. You can try at 0.6. What is the temperature? Is it going beyond or not? Perfect. Now, one more thing which we can find here is what is the maximum variation within this interval, right? So within this interval, after the administration of the first and before the administration of the second time of the new medicine. So you can also find the maximum value here, which is predicted to be at 1, right? So you can find the value of the function r of 1, right? So r of 1 will give you the maximum variation. So in our formula here, if I substitute 1 here, I get 5 times 1 minus 0.5 is 0.5 times 1 minus 1.5 is minus 0.5, and then 1 minus 2 is minus 1. So that is what we get. So we get 125, right? So 1.25 is the variation, right? So 5 times 5 is 25 times 5, 125. So 1.25 is actually the variation. So this position will be 36.85 plus 1.25. So say 1.25. So approximately this will go up to 5, 0, and 8, 38.05, right? That is what it indicates, correct? So that is your maximum value. So that is what it is trying to represent in the present case. Now there are many other cases which you could discuss with the same medicine and might be of interest to many of you. However, you see an approach here to solve such a question, and that is kind of important. So here we utilized our knowledge about the remainder theorem. We found that 0.5 could be a factor, so we used the factor theorem. Once we got t minus half as one of our factors, we did the long division. You could do synthetic division, got the quadratic equation, used the quadratic formula to find the other factors, and then we predicted when are the t-intercepts, which is the normal body temperature for this case, and thereby we answered most of the questions pertaining to the given situation. I hope that makes sense. Feel free to write your comments, share your views, and Zafri, thanks a lot once again for posting this brilliant question, and I'm sure many of our viewers will appreciate it. Thanks and all the best.